So last video you guys saw what is the deviation caused by a prism for a ray of light. Now what we are doing is minimum deviation. See, when we talk about minimum deviation, see, this is basically the figure what you saw in the last video, right? So delta was the deviation, I and E are the incident and the emergent angles, R1 and R2. So we have different variables, correct? Now, when we talk about minimum deviation, what we have is we'll try to change the value of I so that I and E will become the same. At that point, what is the value of delta? Okay, or minimum deviation. So delta has to be 0. Okay, so when delta becomes 0, that's what we call the minimum deviation, you can see. Okay, so what we do is we draw a graph. Okay, so let's say we'll try to write the x-axis and y-axis. So in the x-axis and y-axis, so what we take is the y-axis to be the value of delta, alright, and the x-axis is the incident angle. So as we change the incident angle, what happens to delta? So when we plot this, so what we get is we get a curve something like this. Okay, so we get a curve something like this. So here if you look at it, only at one point it's minimum, correct? Right. So that value is what we call as angle of minimum deviation. So at this point. So here we'll call it as I, the angle of minimum deviation. Now if you look at it, see, if I make a, let's say I'll make it to be a parallel line. So here if you look at it, for every other angle apart from this one, you have two incident angles, correct? See here for this deviation, this, if you take it, you have one here, you have one here. So there are two angle of incidences. Only at I you have the minimum deviation, correct? So at this point, so we'll call this value as delta M. Okay, so we are trying to find what is the refractive index of the prism or of the material using delta M. Okay, again I'll repeat, at delta M we have I and E to be the same, and R1 and R2 will also be the same, correct? Because QR will become parallel to BC, right? So what we get is at delta is equal to delta M, meaning at minimum deviation we have I is equal to E and R1 is equal to R2. Let's say we'll call it as R. Okay, now by the previous derivation what we got, so remember that one, A plus delta is equal to I plus E, correct? So here we have A plus delta M is equal to 2 times of I, right? So I is equal to A plus delta M divided by 2, right? So this is one equation. Next we had R1 plus R2 is equal to A, right? But R1 and R2 are the same, we'll call it as R. So we have 2R is equal to A, R is equal to A divided by 2. We have I, we have R. Now what is the formula for mu? We have mu is equal to sine of I divided by sine of R. So substitute I and R value. So once you do that, we will get mu is equal to sine of A plus delta M by 2 divided by sine of A by 2. So this is the refractive index of a material when it undergoes minimum deviation. Okay, so we have mu is equal to sine of A plus delta M by 2 divided by sine A by 2. So using this we solve few problems and it has a lot of practical applications.